Let's see what's required from the system software that provides support for RPCs. First, the model of interprocess interactions that the RPC model is intended for needs to match client-server interactions. A server supports some potentially complex service. Maybe it's running a complex computation but really fast. Or maybe it's a file service that services a remote file content. The clients do not need to have the same capabilities, or they don't have to be able to perform accesses to the same data. They just need to be able to issue requests to the server for whatever they need. The second requirement has to do with the fact that when RPC was first developed, the state-of-the-art programming languages were procedural languages, including BASIC and Pascal and Fortran and C. Since this is what programmers were familiar with, one goal of the RPC systems was to simplify the development of distributed applications underneath a procedure call interface. This is why the term remote procedure calls came to be. As a result, RPCs are intended to have similar synchronous semantics, just like regular procedure calls. What that means is that when a process makes a remote procedure calls, the calling process, or at least the calling thread, will block and wait until the procedure completes and then returns the result. This is the exact same thing that happens when we call a procedure in a single address space. The execution of the thread will reach the point when the procedure call is made. At that point, we jump somewhere in the address space where the procedure is implemented. The actual original thread of execution will not advance beyond that procedure call point until we get the results from the procedure. And then when we move on to the next step, we actually already have the results. So this is what we mean by the synchronous call semantics, and this is what we require from the RPC systems as well. RPCs have other useful features that are similar to regular procedure calls, and one is type checking. If you pass to a procedure an argument that's of the wrong type, you'll receive some kind of error. So this is one useful reason why RPC systems would incorporate type checking mechanisms. In addition, type checking mechanisms are useful because they allow us in certain ways to optimize the implementation of the RPC runtime. When packets are being sent among two machines, it's just a bunch of bytes that reach from one endpoint to another, and some notion about the types of the data that's packaged into those bytes can be useful when the RPC runtime is trying to interpret what do these bytes mean. Are they integers? Are they a file? Do I need to put them together so as to create some kind of image or some kind of array? This is what the type information can be used for. Since the client and the server may run on different machines, there may be differences in how they represent certain data types. For instance, machines may differ in the way they use big endian or little endian format to represent integers. This determines whether the most significant byte of that integer is in the first or in the last position in the sequence of bytes that corresponds to the integer. Or machines may differ in their representation of floating point numbers, may use different representations for negative numbers. The RPC system should hide all of these differences from the programmer. It should make sure that data is correctly transported, and it must perform any of the necessary conversions, any of the necessary translations among the two machines. One way to deal with this conversion is for the RPC runtime and both endpoints to agree upon a single data representation for the data types. For instance, it can agree that everything will be represented in the network format. Then there is no need for the two endpoints to negotiate exactly how data should be encoded, exactly how data should be represented. Finally, RPC is intended to be more than just a transport-level protocol like TCP and UDP that worries about sending packets from one endpoint to another in an ordered or reliable way. RPC should support underneath different kinds of protocols, so we should be able to carry out the same types of client-server interactions regardless of whether the two machines use UDP or TCP or some other protocol to communicate. But RPC should also incorporate some higher-level mechanisms like access control or authentication or fault tolerance. For instance, if a server is not responding, a client can retry and reissue the same request to either the same server, or it can make an attempt to contact a replica of that original server that it was trying to contact.